All right, welcome to the stream, guys. In this stream, we are going to continue with Nand2Tetris series. And in this stream, we are going to continue building the program counter chip, which we were unable to build in the last stream. So let's open up the HDL file of program counter. All right, so we made quite a mess in the last stream. So let's first check, review what a program counter is. Right, so this is the functionality of a program counter. It takes in input and gives out output, and it also has three we can say status inputs: load, incrementer, and reset. If the reset bit is set, then the register is set to 0. If load bit is set, then whatever we pass as input, it will be set inside the register. And when the incrementer bit is set, it will take whatever value was inside the register in the previous time unit and add 1 to it and give it as the output. As I said already, we made quite a mess in the last stream. Just look at this drawing. So we might have to rethink from scratch this time. So let's see, a program counter. If we think from the first principles, it is going to have a register for storing the value, right? So a register is must. We need a register. So we have got the register in the HDL file. Now this register will hold some value, and initially that value will be 0, which is normal. Okay, but now we also want to change the value of inside the register based on these three inputs: load, incrementer, and reset. And reset bit overrides this both inputs, and if reset bit is 0, then load bit overrides the incrementer, and if load bit is 0, then incrementer bit is 1, then it will have its effect. And if it is 0 as well, then this is the last case. The output will remain same as the previous output. All right, so from where should we start? we have, let's review what we did in the last string. And these are the operations that we basically do to get selector 1, selector 0. So we don't need to review this. So all this code refers to this truth table. We are basically doing the operations on this 3 input to get this kind of output for selector bit 0 and 1. We have got it inside selector bit 0 and 1. Now we have to implement the logic of, say, incrementer. Now this incrementer takes the output as the input and gives the output inside inc1. Let's try to load this script first of all. Okay, it is going to give us error because we have connected this output pin on 32 line. We have connected this output pin to the input. Can't connect gates output. Gates output pin to part. Because this will create a loop and we don't want to do that, but we need the incremented value of the output. So how are we going to do that? Let's see. First of all, we are selecting based on the value of selection bit 0 and 1. We are selecting either false input incremented value or output inside R1. But we already saw in the last stream that it was not working, even though we were selecting properly. The R1 didn't get the value of these inputs. Okay, let me edit this input. Let's just pick a simple case and try to implement that. Let's first try to load the value, right? Because that loading is central to program counter. In all of this case, we are going to load anyway. For all of these 3 cases, for final cases, for the final case we are not going to load anything, but for load, incrementer and reset, we are going to load the value anyway. So we should implement that first. So for loading, we have to pass 1 to this load bit, and when we pass 1 to this load bit, whatever we provide as input will be inside the register, and also it will be given as the output on the next time unit if the load bit is 1. So let me try to comment this first. Let's comment this as well, and this as well. We have got the register we are passing in the input, providing the output. Let's edit this. Let's just pass can't directly provide the input. Let's pass the input directly. So we are not doing anything, we are just passing the input, and we are passing the load bit as it is. Cool. Now let's try to load that script. Still giving us the error, even though we have it, we didn't save it. On 36. Oh, then I will comment with this 36 line as well. Alright, so we are passing here whatever we get as input to input, and we are passing whatever we get as load to load and output. So let's say if I input 4 and do clock cycle, nothing is going to happen. Correct. If I pass 1 to load and do tick tock, then it is going to pass the input to the output. Good. So the loading operation is working. Nice. Now what we want to do, suppose if load bit is 0, then the output is going to be same. That is also working. So we have the last case. When the load bit is 0, we are going to get the output, the same output which was on in the previous time unit. Good. Now we have to implement this logic. So first let's try to implement the logic of reset. There's no such thing as first, I guess, because we have to implement the logic of all of these three things simultaneously. So let's see how we can do that. We already got this kind of logic where we can select bit 0 and 1 based on this, and we can pass it to a marks 4 way to select either false input, increment 1, and output. Okay, so let's remove this from the command and see if you are getting the output in the R1. Let's reset it. Let's save this as well. Now let's load the program counter script. It is giving us error that can't connect gates output pin to part. This can't connect output to directly to the input. Okay. Let's first confirm it if it is giving us the error for this input. So for testing, let's just pass true over here. Okay. Now let's load it. It is saying on the 41th. What is 41? There's no 41. Ink 1 has no source pin because we have not defined ink 1 yet. If we have not defined ink 1 yet, how are we going to use it? But we need the incrementer part. Let's also get rid of ink 1 for now and pass through over here as well. Now let's load it. Now we want to check if we pass selected bit 0 and 1, it will be getting -1 because false an input. This is 0 0 0 1 1 0 and 1 1. So if I passing 0 0, it should pass false to R1, which is correct. Now if I pass 0 1, then 0 1 corresponds to 0 and 1 corresponds to either 0 1 0 or 0 1 1. So for the load bit is for the value 1 for the load bit. Now it should contain input inside R1 as per the logic. We are not getting the input. Okay, wait, we have not changed the value of input. Now if we try to do it, nothing is happening. We are not getting the input inside R1. Even though selected bit 0 is 0 and selected bit 1 is 0 as well, wait, both are 0. Why are both of those values 0? It should be 1 in case of load bit being 1 and incrementer bit being 0 or 1. The selected bit 1 should also be 1. That means there's a problem in this logic. We're getting M1 as 1. What is M1? M1 is OR of load and not increment. Okay. Let me try to put the values, these values inside this equation. So if I put 0 1 0 inside this equation, so not response means it is 1 and load should be 1 or not increment means it is 1 as well. So then 1, this will be 1 1 1, it will be equal to 1, but in our case it is not equal to 1. That means we have not correctly implemented the logic. Let's recheck it. First we are getting the negated inputs for reset, load and incrementer. Inside not reset, not lock and not increment. Okay, now we are passing it to AND for this not res and not load, and we get it inside selected bit 0. Cool. Now we are passing load and not incrementer to OR and getting it inside M1. We're getting M1 as 1. Alright, now we are passing that M1 and not res to AND and passing it to cell 1. So if not res is 1 and M1 is also 1, then cell 1 should also be 1, but it is showing the 0 over here. What's the issue then? Why are we not getting one inside cell 1. Cell 1, we are getting 0 inside cell 1. That means either M1 is 0 or not res is 0. Alright, not res is 0. Why is it 0? It should be this, all of this input should be 1. Why are this 0? We are getting only note load as 1. All of the other inputs remain 0. Why is that the case? Changing the value somewhere. We are passing it to not. We should get the not operation working. Let me comment this lines and see then if it works or not. Now let's try to reload it again. It is saying line 41, cell 0 has no source. Because I need to comment this line as well. Okay, now we are getting 1 inside this 3 registers. If I change input is equal to 1, the input is changing. If I pass increment is equal to 1, wait, the not incrementer is not giving us 1. Why are all of these values reset? The simulator is working very weirdly. Somehow I'm not getting the negated inputs. Why that should be the case, I don't know. Maybe it is working like that because of the sequential logic. If I reset all of this and just pass 1 as the load. Wait, now I'm getting 1 inside both of this. Is the program, is this simulator buggy or what? It is giving me 1 inside, not response and not increment. Oh, okay, wait. It is correct because as per the input. Now if I put 0 over here, it is giving me 1. If I put 1, great, it is working. Then why was it not working earlier? It is working correctly. Right, now it is not working. Sometimes it works and sometimes it doesn't. Now it is working, but it is showing us incorrect output. Wait, are this load, increment and reset operators clocked? Because that might be the reason we have uncertainty in the outputs. Let me try to open up the built-in chips, built-in program counter. So this is the built-in program, and yeah, I was right. The load, increment and reset are clocked as in this program counter. So maybe that's the reason we are getting this kind of uncertain output. Does that mean we can't use this logic? If this doesn't work, then we can't use this mux. But even if this inputs are clocked, we should get the input and the output inside this registers, this variables, I mean. Let's suppose if they were clocked, then what would happen? If we provide input to not register, not gate, I mean, it should give us the output, correct output inside this variable. If they were clocked, then now we are getting it. We are not getting it once, we are getting it now. Let's try to get it again. We are getting it. Let me try to get it by setting incrementer bit first. We're getting it. We're getting the output. Wait, but now it is incorrect. Set all of them to 0. Wait, they are showing reset load and incrementer as timed a bit as well. So that means they are clocked. So that explains the weird behavior of this NOT gates. That means we have to get rid of this logic. Let me try to load the script and see the output. We got the correct internal pins for 010. We're getting 11101. So this seems correct. Now let's try to uncomment this mux and see if it is giving us the output inside R1. We first have to uncomment these things. Now let's see if we get the outputs inside this cell 0 and cell 1 or not. Let's load the script in this case as well. The increment is set to 1. That means it was third case. So the selector bit 0 should be 1, and selector bit 0, selector bit 1 should be 0, which is correct. And if I pass load bit as 1, but in that case both of these are zeros, which shouldn't be the case. What the hell? Why isn't it working? And I can't even debug it because I don't even know what it is doing. It is giving me different outputs every time I try to run it. Sometimes it gives me correct selector bits, and sometimes it doesn't. Now it is not giving us this inputs as well. See, that's what I'm talking about. Oh, we can't get this logic working, we won't be able to move on. We can't introduce this logic. This is the first step we have to solve. So let me try to read some more documentation. Maybe there is something in that documentation which will give us hints as to why our script is not working or behaving weirdly. Let's check the clock chip portion. Clock chips are clock regulated, therefore the standard way to test a clock chip is to set its input pin to some value. As with combinational chip, simulate the progression of the clock and watch how the chip logic responds to the ticks and talks. Can be built from register, incrementer, and some logic gate. But these logic gates are not working. What are we going to do? This shitty simulator is not even giving us the debugging errors. How are we going to know our logic is working or not? Probably check other scripts for some hints. Let me check. Yes, bit was the first script that we made for this week 3 project. So let's check it out. For bit we basically got a mux, a DFF, and end. For mux we did this, we provided M1 to input, M1 to A, and input to B. Okay, and selector bit is equal to load and output inside V1. So whenever the selector bit was 0, we selected whatever was inside M1. So initially there was just, because V1 was, oh wait, it is cyclical. Initially M1 and V1 both contain 0. So for DFF the output will be 0 for M1 as well. If the load bit is 0, this will be selected, it will go over to V1. Now if the load bit is 1 and we pass the input to V1 and V1 goes here and goes to DFF. Finally we also do AND operation to get the output. We should have used B is equal to true in this case, but B, both input has same also works for the AND gate. Okay, if both inputs are same, if 0 0, if M1 is 0, we get output 0. If M1 is 1, then we get output as inside this, so it does work. Suppose if we do the similar thing in this case, there was ink 1 over here and output over here, so we can't pass the output, so we will use an intermediate variable like this. We will have output 1. Should be output 1. So now if output 1 is 0, we will have 0 inside output, and if it is 1, wait, but okay, output is also 16-bit. This will do bitwise AND operation, so yeah, it will be correct. And it should be output 1 over here as well. Now let's try to run it. We should also get this incrementer, and this should be output 1. Hopefully it is not giving us any errors. Let's try to load the script. Wait at line 5. What is it giving us? This R1 is not giving us the correct value. Maybe there's some problem with this mux. Let's check the implementation of mux 4-way. It should be inside second guess. It should be inside the first week. Mux 4-way 16. Somehow this R1 remains 0. It is not getting the correct output. We have A, B, C, D, right? We have selector bit 0, set to 0, set to selector bit 0, and selector bit 1 set to selector bit 1. What if this is selected bit 0 and this is selected bit 1? Maybe that is the case. Let me try to swap these selected bits. Let's pass selected bit 1 over here and selected bit 0 over here. Let me try to run it now. Great, but the script didn't work, but we are getting the R1 output now finally. So that was the case. We were passing the incorrect selector bits. So now this are working. We can debug it further. Now if that's the case and we are getting 1 inside the R1, which is correct, but we are still not getting it inside the output. Now let's check why that is the case. Because we are passing the incorrect values to input weight. I guess we have our program counter working now. If I pass R1 over here and let's try to load it again and let it run. I'm 90% sure that it is going to work this time. Oh damn, it didn't. It gave us correct output in R1. Okay, we are getting correct output in R1. Oh yeah, this load bit is incorrect. We should have N1 over here. This should be N1 and we should probably decomment this as well. Okay, let's try to load it again. Holy hell, it is working this time. Guys, our program counter is working. Great. I finally got the program counter working. And do you know what was the bug? We were passing the incorrect selector bit. So all along our whole logic was correct. Only the selector bits were incorrect. So it has done computing all the inputs, then it was successful. That means our script is correct. Now let's clean up our script. Let's delete these commands, get rid of this line as well. Cool, we have got a working program counter as well now. Let me try to load it again to confirm that I didn't break anything while I was deleting the comments. Awesome, we have a program counter which is 100% correct. So after, for in the first stream we almost wasted 2 hours and 32 minutes. Not wasted really, but we took 2 hours and 32 minutes to debug the script, and we couldn't get it to working, and today we got it working after an hour. So this program counter, this little bug, cost us a lot of hours of debugging. I should have focused on this line of code earlier. Then I would have found out the bug and we wouldn't have wasted this much time. But anyway, this is why I love coding. You work for hours on end and something doesn't work, and you try to debug it for hours and hours on end, and finally when it works, the feeling you get is amazing. Alright, so that was the last chip of project 3 section. Let me check what's inside the project 4 now. I haven't gone through the project 4 which is inside week 4. So first I will be reviewing the week 4 first, then I will start implementing the project section of week 4. So alright, so it is the last project section, which is for the machine language. Let me check what kind of chips are inside the week 3 project section. Let's check the projects inside project 4. We have multiplication and IO handling. There are just 2 programs, but it will include all of the previous chips that we have used. Alright guys, then this is it for this stream. I will get back to Nand2Tetris after I have done reviewing the week 4 section and all the videos of that section. So have a nice day or night, whatever it is. Bye bye.